Good morning. I am Ernesto Correa from Capgemini, and today I will talk about distributed processing. Okay, distributed processing improves task computing capabilities and helping to, for example, reduce latency, improve scalability and flexibility, improve system security. Some applications in 6G include augmented virtual reality, Internet of Things, smart cities, autonomous vehicles, and others. In Capgemini, we are working in two projects, 6G data-driven and end-to-end integrations. In the latter, we propose is a computing distributions strategy for some use case reals. What is in distributed processing? Tasks are divided across multiple devices or nodes simultaneously and in a coordinated manner. In this picture, shows some key elements of distributed computing. For example, load balancers, data storage, and processing nodes. This is very important. A processing node is a device or processing unit that is part of the network and allows data processing and task executions. A node can be, for example, an individual computer, and to the service, a mobile device, to the sensor, and integrate component. The nodes of the distributed system are interconnected by a communication network, for example, the internet. A distributed processing strategy is a set of decision and planning operations to efficiently organize, coordinate, and manage data processing. This system must include load balancers, data storage, processing nodes, AI system, communication networks, distributed algorithms, and resource management. To design the distributed processing strategies, questions must be responded. For example, what are the objectives of the system? What are the performance requirements? What resources are needed? What technologies will be used? What are the security requirements? How will system monitoring be carried out? For example, as technologies and tools utilize distributed computing frameworks, middleware, and protocols. In security and privacy requirements, implement encryptions, authentications, and access control mechanisms to protect to that. In system monitoring and diagnostics, for example, employ monitoring tools and diagnostic techniques, etc. The strategy is developed in three phases. The first phase involves an analysis of admission policies, the policies that define requirements for the process to service or to be distributed. For example, process implementable with federate node, information security type, processes priority in case the emergence, medium, and low. The second phase involves an analysis of distribution process requirements. Here, the tasks and activities to be carried out must be defined, as well as the minimum hardware and software requirements. And the last phase involves a distribution optimization analysis. In this part, metrics for the evaluation for the distribution and distribution rules are defined. In this picture is the three phases. And the first one, analysis of admission policies, for example, admission policies for analyze, security level check, and priority check. In the second phase, analysis of requirements of the process to distribute every activity. And finally, in third phase, distribution optimization analysis. And here we define metrics and distribution rules. definitions. Okay, now let's apply this fast to real use case. The object is to determine land cover from hyperspectral image taken from a sensor such as satellite, hubs, or a drone. The activities developing are the following. First, data collections. Various data sources are used to gather information about land use and cover, imaging, processing, and analyze. Here, remote researching techniques are employed to process and analyze the collection data and classifications. Once the data is processed, it is classified in distinct categories representing different land cover and land use types, and finally mapping and visualizations. Here, this picture, the process. One, in the field fast, admission policies must be determined. For example, order according to urgence to request, order based on current workload, and finally, resource reservations policies. In the phase 2, for the next phase, you mostly use case activity and determine the necessary software and hardware requirements. Okay? Data entry requirements, high resolution hyperspectral satellite image are used. In processing requirements, for example, a set of imaging processing algorithms is requirement. Result requirements, high accuracy, for example. And performance and scalability requirements, large volumes of satellite images efficiently and in real time. In security and privacy requirements, security measures to protect satellite image data. Okay, and finally, in the last phase, metrics must be defined to distributing the processing, and here to evaluate metrics, processing time, load balancing, resource utilization, and communications latency. In communication latencies, evaluates the time required to transfer data between processing nodes. And in distribution condition rules, for example, distribution by geographic proximity, priorities the assignment of satellite image to the geographically closest processing nodes to minimization communication latency, and dynamic load balancing, and finally, prioritization of critical image. Okay, thank you.